Hello, my name is Sarah Sharples and my student number is 2545830. And today I'll be sharing my reflection on what I've learned in civil and environmental engineering. Throughout this course, I've explored everything from the architectural marvel of the Quakewater Tower to designing flood-safe bridges to diving into the world of technical drawings with AutoCAD. This task has been the chance to not only apply what I've learned, but to reflect on how each experience is shaping me into the kind of civil engineer I hope to become. For our first assignment, we were asked to write an engineering report on a structure that captured our interest. I chose the Quakewater Tower, not just for its striking architecture, but because I was fascinated by how something so massive, with its growing floor plate size and rotating blocks, could be supported on such a compact base. The floating cantilevers especially left me in awe. As I dove deeper into my research, I realized how architecture is pushing the boundaries of creativity, and in doing so, it challenges engineers to push the limits of what's structurally possible. What really inspired me was seeing how a team of engineers, project managers, and construction workers work collaboratively to bring this innovative design to life. Throughout reports and articles, I explored everything from the history of the site and the conditions of the original AMP Center to the design constraints, structural systems, unique construction methods, and how environmental factors like wind and sunlight influence the design. I also learnt about the building's sustainable construction practices and how cost efficiency was achieved without compromising innovation. One of the most exciting discoveries for me was that the Quakewater Tower is an upcycled skyscraper. As someone who loves thrifting and DIY projects, turning old jewelry into something new or reworking clothes instead of buying fast fashion, this approach really resonated with me. The idea that a structure, rather than being demolished and rebuilt, could be transformed and elevated into something entirely new aligns with the kind of engineer I want to become, one who values sustainability and innovation equally. I was also intrigued by how the building was designed to respond to its surrounding, particularly in the way that it manages solar heat and wind pressure. It showed me that engineering isn't isolated to the structure itself, but deeply connected to its environment. This assignment helped me understand how important it is to consider comfort and the environmental forces when designing for the real world. I also learned that engineering is about finding the right balance between constructing something that's easy to build, cost effective, and safe. At first glance, these goals often seem to conflict with one another. What's cheaper may compromise safety, and what's easier may increase costs. As a first year student, I found it difficult to imagine how experienced engineers navigate these trade offs and still manage to deliver world class structures. However, through researching the Quakewater Tower, it opened my eyes to how critical planning, teamwork, and experience are in developing construction methods that don't sacrifice one goal for another. Most importantly, I realized that engineering isn't just a series of steps you follow. It's about adapting to each unique situation, using creativity and problem solving to meet complex challenges. We're not just building structures, we're crafting solutions that are smart, sustainable, and forward thinking. For assignment task 2, my group and I were challenged to design a bridge using real world data and mathematical modeling. It wasn't just about crunching numbers, though, it was about applying them to something tangible, something that we could potentially impact lives. One of the first things I learnt was how to interpret rainfall data from the Bureau of Meteorology. From there, we applied both the annual reoccurrence interval method and the rational method to estimate the maximum flood rate for a specific river. It was here that I discovered something crucial. Unlike math, engineering doesn't always give you just one correct answer. Different methods can lead to different outcomes, and it's the engineer's responsibility to choose the most sustainable one, usually by considering the worst case scenario to ensure the public safety. That shift in mindset has really stuck with me. Next, I used Excel to estimate the maximum height the floodwaters could reach. At first, I thought this would take hours of trial and error, but then I discovered the goal seek function. Honestly, it felt like magic. I had my answer in minutes. That moment showed me the power of technology and how, as future engineers, we need to embrace and master the tools that make us more efficient and precise. But technology isn't perfect. As part of our assignment, we double checked our answers with Copilot, and to my surprise, it got every answer wrong. It reminded me that while AI can be helpful, it lacks critical thinking and contextual awareness. Engineering requires experience, judgment, and collaboration, qualities AI simply can't replicate. It was a wake-up call. I can't rely on shortcuts. I need to develop my own skills and trust the expertise of real people around me. And speaking of people, working in a group of 5 taught me some invaluable lessons about collaboration. I'll admit, sometimes I think I can do everything on my own, but engineering is never a solo mission. It's about working alongside architects, project managers, and builders. I learnt how to communicate clearly, delegate fairly, and hold each other accountable. That experience not only helped us meet deadlines, but it also made us a better teammate and one step closer to becoming the kind of civil engineer I aspire to be. This assignment taught me more than just technical skills. It taught me the importance of teamwork, responsibility, and thinking beyond the numbers. And that's something I'll carry with me into every project I take on in the future. For assignment task 3, we began learning how to use AutoCAD, and honestly, I've never been more excited in my life. There's something so satisfying about engineering drawings. They combine the precision of maths and science with the creativity of art, and I found myself drawn to the beauty of a perfectly labeled, technically accurate structure. But I'll admit, I underestimated how tricky it would be. While I love the idea of technical drawings, I quickly discovered that they're detailed, precise, and sometimes painfully slow to get right. It took me a little while to get the hang of things, but I've genuinely enjoyed the challenge. So far, I've learnt how to insert lines and shapes, adjust their dimensions, and label them correctly. I've also picked up little tricks, like how it's actually better to draw a rectangle instead of 4 individual lines if I want to center a circle perfectly inside it. That might sound like a small detail, but it taught me something really important. Learning isn't just about knowing how to do something, it's about figuring out how to do it smarter, faster, and more efficiently. While there's still so much to learn about AutoCAD and other design software, this experience has taught me something bigger: the value of patience and persistence when learning something new. Even when the process feels slow and confusing, what keeps me going is the thought that one day I'll be able to create intricate, detailed engineering drawings with confidence. This task reminded me that becoming an engineer isn't about mastering everything at once. It's about embracing the learning curve, pushing through the frustration, and finding joy in the process. It helped me realize that every new skill, even the tough ones, bring me closer to the kind of engineer I want to be. Someone who is curious, capable, and always ready to learn. In conclusion, this course has been an incredible journey so far. From analyzing the breathtaking structure of the Quakewater Tower, to designing a bridge with flood data and calculations, to navigating the intricate world of AutoCAD, I've learnt so much in such a short time. But what really stuck with me is that learning engineering isn't just about acquiring knowledge. It's about developing the mindset to question, explore, and solve problems creatively and collaboratively. And while I've gained a wide range of new skills, this course has also made me realize just how much I still don't know. But instead of feeling discouraged, I feel more inspired than ever. That realization has sparked a deep curiosity in me, a desire to keep learning, to keep growing, and to embrace every challenge that comes my way as I continue my journey to becoming an engineer. Thank you.